Good morning, everybody. My name is Kiran Patil, and today I am going to illustrate how to perform the experiment of conversion of DC to DC using step-down chopper on the PSIM software. So, in this, we have to perform the simulation of the step-down chopper. So, all of you know the step-down chopper means the output we are getting is the less than the input voltage. Okay, so this circuit you have to simulate. So this is the nothing but the DC power supply. This is the switch. So here you can use any power semiconductor device. So this is also called chopper. So main part of this circuit is this particular chopper which chops the output voltage. That means here at the output we will getting the variable DC output voltage. Here you have to use the getting signal. So there you can use either the frequency control or PWM control. Okay, and other devices are nothing but this diode and this inductor. Okay, then I will tell you what actually we have to perform in this particular experiment. Okay, so when you do the simulation you can easily see the waveforms also. Okay, that means what we are going to do here, we will place one voltmeter here across this DC power supply and one another voltmeter across this load. Okay, and we will get the waveforms for input voltage as well as output voltage. So there you can easily see the input voltage is the fixed DC voltage, whereas the output voltage is the variable output voltage. Okay, and that output voltage is changed by the duty cycle of this getting signal. So here this observation table we have to take. You have to take the different duty cycle 50%, 25% and 75%, and this for particular duty cycle you have to measure the output voltage. Okay, and input voltage is fixed. Here in this case we are giving the 24 volt as the input. Okay, and the frequency is the 1 kilohertz. Okay, actually frequency does not play any part, so you can keep 1 kilohertz, 2 kilohertz or 5 kilohertz frequency. So here suppose duty cycle is 50%, so output voltage is calculated by using formula E0 is equal to alpha into EDC. So EDC is nothing but the 24 volt, that is input voltage, and here alpha means 50 means 0.5, so 0.5 into 24, that will be 12 volt. So that is the theoretical output voltage. Okay, then for 25%, that here 0.25 into 24, that it will be 6. Then 75% means it will be 0.75 into 24, so that will be 18 volt. So these are theoretical output, and you have to write here the measured output voltage. Okay, so you can take other readings also. So now we will see the simulation on the PSIM software. So this PSIM software I downloaded from the Google. So first, when you are starting the PSIM, these are the windows. Okay, that you will see. First, when you want to start the new design, you have to just go to the new. Okay, and here you can design the different circuits. Okay, so different components are given here, so you can take the components. Some additional components if you require, they are also there at the left side. Okay, so we know the first we require the DC voltmeter, so we'll take that DC voltmeter. Then we require the switch. Okay, so this is the different types of switches are available here. That is, this is nothing but the MOSFET switch. Then this is the IGBT, so we'll take the IGBT switch. Then we require diode, so we'll take the diode models are here, we take the diode. Then inductor is here, so we'll take the inductor and the resistor. Okay, so all the components are here below. You can just move the cursor on that particular component. So name comes below, so you can identify that particular component. Okay, then you have to take this wire and connect the circuit. So before that, this need to be moved, rotate. So you have to rotate like this. Then this also need to be rotate. Then this is the inductor and this is the resistor. Then all these components you have to connect by using this wire. So wire you will get here. So just connect like this. Then from here to diode. From here to resistor. So this is the simulation of step down chopper. Okay, now you have to also make the ground. So take this ground. So this is a ground you have made, and here you have to give the gating signal. That means you have to vary the duty cycle by using this gating signal. Okay, now you have to measure the voltage. So for that you need to take the two voltmeters like here. So this kind of voltmeter is also voltage probe. It does not require the ground. Okay, then same here you have to connect. So this voltmeter will measure the output, whereas this voltmeter measure the input. Then press accept. Okay, then you have to do the settings of each and every component. So for that you have to just click on that particular component, double click. Okay, so here amplitude we have to make is the 24 volt. Then this voltmeter, so here instead of V1 we will give it name as the input. Then this is the IGBT switch, so keep it as it is. Then this gating signal. Okay, so we know that we are going to keep the frequency of 1 kilohertz, that is 1000 hertz. Okay, so these two things are important, so that will decide the duty cycle. Okay, so number of points will be 2, and which are the switching points will be nothing but the 0 and 180. Okay, that means we know the total cycle of any waveform is 360 degree. So 180 is at 50%, so we know that T on will be 50% and T off will be 50%. That's why for this case we will get the 50% duty cycle. For 25% duty cycle, here you have to give the 90. Okay, and for 75% duty cycle, here you have to give the 270. So we'll get the 75% duty cycle. Okay, so if you want the 10% duty cycle, that means here you have to give the 36. Okay, that is 10% of 360. Then close this. Diode keep as it is. Inductor also. Only thing is that just make it as a micro. Then resistor value also keep it like this only. default value, that is 10 ohm resistance. Load resistance, this is load resistance. Okay, after all these things, what you have to do, you have to save this simulation. Okay, so I will give some name, step down chopper final, and click on save. Then this particular thing you can now simulate. So for that you have to go here and click on simulation. So actually V2 is nothing but the output that we need to write here. V2 will be output. Then just this you have to click, that is run PSIM simulation. Okay, so here we'll get the two variables, that is input and output. Okay, so if you take both the variables at the right thing, what will happen, both the variables will be shown in single window. Okay, but will display it in the different windows. So here you can see the input is the 24 volt, which is the constant DC voltage. Now we have to see the output. So for that you have to click on this particular add-on screen and click on output, add. Okay, so here you can see the output. So here you can see the output, you will get the 50% duty cycle. Okay, so output is the variable output, this is the fixed output, and this is the variable output, that is input is fixed DC whereas the output is variable DC. Okay, now if you want to measure, here just you can click on the measure and click measure. Okay, so basically the output voltage, here you have to take the average voltage. So here you can see the input voltage is nothing but a 2.4 exponential 1, that means it is 24 volt. Okay, similarly here 1.2 exponential 01, that means it is 12 volt. Okay, so that we will write here 12 volt. Here also we are getting the same result, that is 12. Now we'll check for another, that means here you have to write the for 25 degree, for 25 it is the 90. Then click on simulation. First input we'll see, then we'll see the output. Okay, so you can see here 25% duty cycle. Okay, so this is the T on and this is the T off. T on is at 90 degree and T off means T off is from 90 degree to 270 degree, so it is larger. So average output voltage you have to see. So average output voltage you have to go here and measure. Okay, so here you have to see the average output voltage. So here you can see the input voltage is 2.4 exponential 001, that means it is 24 volt, and the output voltage is 6.00 exponential 0, that means it is 6 volt. Okay, so that you can mention here. Here we are getting the 6 volt. Then we will take for another reading, that is 75%. So for that you have to just change this switching point. So here it is nothing but the 270. Then close it, then again simulate it. So first is the input, add it, see it. Okay, that will be 25 volt fixed DC. Then go to another window, click on output, add, and OK. Okay, so here you can also see the 75% duty cycle. Now we have to see the average DC output voltage. Okay, so measure. So here you can see the average. It is nothing but input is nothing but 2.4 exponential 1, that is 24 volt, and here 1.7 exponential E, that means it is 70.99 volt. Okay, so here you can write it is 17.99. So almost the measured output voltage is near to the theoretical output. Okay, here 50% we are getting the 12 volt, for 25% we are getting the 6 volt, and now for 75% we are getting 17.99 and 18 volt. So in this way we have simulated the step down chopper with the PSIM software. Thank you.